Okay, Assalamualaikum warahmatullahi wabarakatuh and good evening.
Waalaikumsalam, sir.
Ada yang ter-remove tak? Saya perasan ada Syed Hussein Al-Atas, ada tak? Hussein Al-Atas. I think when I try to record, uh, it remove Hussein Al-Atas. Please, if you friend with Hussein, please ask him to join our session. Ada simbol record kan? Saya takut meeting kita tak record eh. I hope our meeting will be record. Alright, so for today, let's just recap what we have learned last week, and then if we have time, we will learn the last subtopic, which is the applications of first order linear differential equation. So far, what we have learned is the three method, separable equation, and then we also have a linear equation. And the last one that we have learned last week is exact equation. All right, so for exact equation, let's do some recap. So for general form of exact equation, so the equation or the differential equation must be in this form. So we have a function of m consists of variable x and y, where m is the derivative of dx plus some function n xy dy. So this function must equal to 0. So in order for this equation to be exact equation, first you must write in the general form, and then you must show that this equation is exact equation by doing the test for exactness. So doing the test for exactness, you have two functions. First function m. So you take the function m and you find the partial derivative with respect to y. And then you take a function n, and then you do the partial derivative with respect to x. And then you compare between this partial derivative. If the del m over del y are equal to del n over del n, if this is satisfied, then you can proceed with the methods of exact equation. All right, so for the solutions of exact equation, first let's define the solution. So the solution that we are going to find is in the form of fxy equal to constant c. So this is the solution that we are interested. So the solution must be some function xy. So in this function, we have a variable x and y, and this function are equal to some constant c. And to get the function fxy, you can start either with a function m, or you maybe want to start with function n. Let's say we take a function m. So to find fxy, you need to differentiate m with respect to dx, and then you plus some function ay. So integration of m with respect to dx plus function ay. Don't forget a function, unknown function ay. So after you differentiate this one, you will get a fxy with some function ay. Then you differentiate fxy with respect to y. So first you integrate with respect to dx, and then you differentiate with respect to y, and then this one will be a prime y. And then the derivative now must be set equal to function n. So must equate to n xy. And then you identify what is the a prime y. Find ay by integrating a prime y with respect to y, and then substitute the function ay into the equation that you integrate in number 3. If the given initial condition, you can find the constancy with the particular solution. So we already seen this example. So I hope you study the example, and then let's see exercise 2.4. So let's do the exercise 2.4. I hope you already do this exercise. So this is just a solution for exercise 2.4. So in the problem 1 to 20, determine whether the given differential equation is exact. So you need to determine first whether this equation is exact or not. If it is exact, you need to solve it. If not exact, no need to solve. So we will do the odd numbers only. So the first one is 2x minus 1 dx plus 3y plus 7 dy equal to 0. So we need to determine whether this equation is exact or not exact. So this is exercise 2.4, number 1. So we have 2x minus 1 dx plus 3y plus 7 dy equal to 0. First, determine whether this equation is exact or not. So this equation already in general form. So in general form, you must have a function m here and a function n. M is derivative x, n is derivative y, and to be in general form, both must equal to 0. Remember, it must equal to 0. So let's rename this one. Let's say this is m. This is a function n. So a function m is 2x minus 1, while, while the function n is 3y plus 7. So find the partial derivative m with respect to y. So since function m all in x, that means we are differentiating constant, so we get 0 because we don't have any variable y. So we treat other than y as constant. So 2x is a constant, minus 1 is also constant, so differentiate constant, we get 0. Function n, differentiate derivative del n over del x. So there are no variable x, so 3y is the constant, plus 7 also constant. That means both derivatives are 0, hence we make a conclusion del m over del y equal to del n over del x. So this is a exact equation. So we must solve by using exact equation method. So this is exact equation. So we are going to solve this one by using exact equation method. All right, so to find the solution first, the solution must be in terms of x, y, where this function is equal to some constant c. So to get a function fxy, so you must integrate whatever m or n with their respective value plus some function ay or ax. So in this example, I would like to use the function m. So I need to differentiate m. So here we have function m with respect to x. So m dx plus some function ay. So what is our function m? M is 2x minus 1. So integrations of 2x minus 1 dx plus ay. So when we are integrating with respect to x, so every variable other than x are constant. So first we have 2x, so integrate 2x, we have 2x squared over 2 minus 1, so minus x, and then plus ay. So 2 over 2 is 1, so we have x squared minus x plus ay. And then we are going to differentiate, partial differentiate. So we are doing del f over del y. So del f over del y must equal to function n. So we are integrating this function. This is f. So with respect to y. So this is x squared. When we are differentiating x squared, we get 0. We get 0. Then differentiating minus x, also 0. Differentiating ay, so we get a prime y. So this must equal to n, hence our n is 3y plus 7. 3y plus 7. So we have a prime y equal to 3y plus 7. So ay equal to integrations of 3y plus 7 with respect to y. So we have 3y squared over 2 plus 7y. So this is our ay. And actually this one, when we integrating, we get a constant c. Let's say this is c1. So since our solution f x y must equal to some constant c, let's say this is c2. So we write back fxy. So fxy is, take here, this is our f. So this is actually fxy. And the unknown function ay is this one. So you combine with this one. So we have xy equal to x squared minus x plus 3y squared over 2 plus 7y. And then this is equal to c, where I don't need to write this one, but I just want to mention that this c actually is c2 minus c1. So this one, you don't need to write this one, but I just want you to understand where I got C. Alright, so if you didn't have time to write all the answer, please snapshot the screen. So take a screenshot of the screen, and then we can proceed to the next example, exercise number 3. Question number 3. So number 3, 5x plus 4y dx plus 4x minus 8y cubed. 5x plus 4y dx plus 4x minus 8y cubed. dy equal to. If you have any question, you can write in the chat box. If you don't understand, or if I going too fast, you can write in the chat box if you have any problem or question. Or you can raise your hand. I will give you time to give your question. First, we need to identify this is M, this is N. So M is, so let's write M. m equal to 5x plus 4y, n equal to 4x minus 8y cubed. So to test the exactness, find derivative m over y. So del m over del y. So 5x is a constant. So the derivative will be 4. And then for n, find the partial with respect to x. So here we only have 4x, so we get 4. And minus 8y cubed is constant, so 0. So both are giving the same numbers. 4 and del m over del y are equal to del n over del x. So the conclusion, this is exact equation. So this is exact equation. So since this is exact equation, now let's try to find the solutions of this question. So the solution will be some function f x y equal to c. So remember, this is exactly what is our solution look like. We are going to find this solution. So to find the solution, we are find by integrating m or n. In the first one, we do m. Now let's try do with n. If you think m is easy, you can try m. If you think n is easy, you find that n is easy, you can try n. Both will give you the same answer. So now let's try do n. So f x y are equal to integrations of n. So remember that n is with respect to y. So you need to integrate n with respect to y also. N plus function ax. So integrations of n. What is n? 4x minus 8y cubed. 4x minus 8y cubed with respect to y plus ax. So 4x, when we are integrating with respect to y, so 4x is a constant, so you will get 4x y minus 8y cubed. So cube is 3 plus 1, so to the power of 4 divided by 4. So 8 divided by 4, so we get 2y to the power of 4 plus ax. So let's rewrite this one. fxy is 4xy minus 2y to the power of 4 plus ax. Now we are looking what is ax. So to find ax, first you need to differentiate f with respect to x. So now to find ax, so you need to find f with respect to x. So differentiate this one with respect to x. So when we are differentiating with respect to x, so this is variable x, that means 4y is a constant. So you will get 4y. 2y, 4 is constant, so 0. And then this is equal constant, so plus a prime x. Del f over del x. And this one you must set, it must equal to m. So let me write this one. Del f over del x must equal to m. So this one must equal to 5x plus 4y. So m is 5x plus 4y. This is our m. So when we find the partial f with respect to x, so we must set equal to m. So now let's compare. So this function, we have 4y, here also 4y. That means a prime x is 5x. So a prime x is 5x. We are not looking a prime x. We want to find ax. So we need to integrate. So integrate 5x with respect to x. So integrating 5x, so we get 5x squared over 2. Then the solution is fxy equal to c. So fxy, our fxy is this one, while ax is this one. So combine all together, 4xy minus 2y to the power of 4 plus 5x squared over 2. This is equal to some constant c. All right, so please take a screenshot. If you didn't finish, copy this one. All right, next one is question number 3 and number 5. I will do one more question. After this, we will look at the last subtopic. One last question. Question number 5. So 5x plus 4y plus 4x minus, sorry, this is question number 3. Question number 5. 2xy squared minus 3 dx plus 2x squared y plus 4 dy equal to 0. Two x y squared minus 3, I think, with respect to x. 2x y squared minus 3x plus 2x squared y plus 4. 2x squared y plus 4 with respect to y. This is equal to 0. So let's mark this m. This one is n. And then our function m is 2xy squared minus 3. Function n is 2x squared y plus 4. Test for exactness. So find del m over del y. So we have 2xy squared. So 4xy minus 0. Del n over del x. So we have 4x y plus 0 also. So both are equal. So del m over del y are equal to del n over del x. And then this one is exact equation. So the solution, fxy must equal to function c. So fxy is integration of lattice m with respect to x plus some function ay. So m integration of 2x y squared minus 3 dx plus ay. So we have 2x square y square over 2 minus 3x plus ay. So 2 over 2 will be 1. So let's rewrite this one. This is fxy. So x square y square minus 3x plus ay. So to find ay, you need to differentiate f with respect to y. And this one must equal to function n. So find the del f over del y. So differentiate with respect to y. So we have x square y. So y the power 1, the power is 1. So 2 is in front. 3x is constant. So plus a prime y. And this is equal to n. Our n is 2 x square y plus 4. So compare this one. We have 2x square, 2x square. So a prime y is 4. A prime y is 4. So what is ay? Integration 4 with respect to y. So this one is 4y. Then combine all together. So our function, the solution will be f fxy equal to c. Let me make it bigger. So fxy x square y square minus 3x plus 4y equal to c. So this is our solution. X square minus 3x plus 4y equal to c. All right. So take a screenshot for this solution. Question number 5. All right, let's take a look for our teaching plan. So now we already covered separable equation. We also covered linear equation and exact equation last week. Yeah. So today we do the exercise. So I hope that all the balance exercise that I left, you try to do by yourself. If you don't know, if you find difficulties or trouble, you can ask me directly lah through the WhatsApp group ataupun your personal WhatsApp me. Yeah. And then we already covered this one. Introduction, we already discussed what is differential equation, method, solution. So all the separable equation. And lastly, so today I will cover application. And for tomorrow, let's do, I will give you some exercise. Let's discuss a few exercise before we move to chapter 2 next week. I will also upload notes on chapter 2 next week. All right, so for application, so there are a few applications of differential equation where you can use to find the solution of a real world problem. For example, law of cooling or warming. We also have a population growth or population decay, and then a few application in the real world. But today I would like to discuss with you what is the Newton's law of cooling. So Newton law of cooling or warming. So there are two things, but the same equation as first Newton law of cooling or warming. So Newton's law of cooling or warming, according to Newton's empirical law of cooling or warming, the rate at which the temperature of a body changes is proportional to the difference between the temperature of the body and the temperature and the surrounding medium, the so-called ambient temperature. So what does Newton mean? So let's try to think this way. So let's say you are in the classroom in DKN 1 and 2. So this is your classroom. So your classroom have a aircon. So this is the aircon switch. So you set the room temperature to be, let's say, 16 degrees Celsius. So now we call the room temperature or this medium we call Tm. The room temperature is 16 degree. This is our room temperature. Now let's say you entered the class. You bring a teh tarik, for example. You buy a hot drink, coffee or teh tarik. So you have a coffee into the class, Ricciamo hot latte coffee. Let's say this coffee, ideally you buy and then you measure the temperature, for example, it is 80 degrees Celsius. You bring into the room, which is 16 degrees Celsius. So what do you expect happen to this coffee? So Newton's law of cooling say that the proportional or the rate of body temperature. So this one we call body temperature. The rate of body temperature are equal to the difference between the body temperature and the surrounding temperature. So Newton say that the rate of body temperature, because this is high, so the temperature will cool down, will be cooling effect on the coffee. The coffee will be cool because it is in the cool room. You bring a hot drink into cool room, what happened to the drink? The drink will be cool. So 80 degree will be cool until the temperature of this coffee will equal to the temperature of the room, which is 16 degrees Celsius. So for how long it will reach 16 degrees Celsius? So we need to solve by using differential equation. So first, let's discuss what Newton say that. Newton say that the rate at which the body temperature change is proportional to the difference between the temperature of the body and the temperature of surrounding. So the rate, when we say a rate, it means dt over T, where T is the temperature of the body. So this capital T is the temperature of body. Body mean this coffee lah. And the small letter T, this is time. So when we say rate, when we are discussing rate, it means it is a derivative of something with respect to time. This is called rate. So if I say, what is the rate of volume? So when I want to ask you, find the rate of volume, that means, let's say V is the volume, so dV over dt. Now, what is the rate of temperature body? So dt capital T over small letter t. So Newton said that the rate of the changes is equal to the is proportional. So the symbol proportional is this one, proportional with the difference between temperature of the body and the surrounding. So difference between temperature of the body, the coffee, and the surrounding. So the surrounding is room, TM, where in this case, the difference is 80 and 16 degrees. So we know that TM is 16 degrees. So when we have this equation, so this is differential equation, but this is just a mathematical representation of what Newton said. So Newton said that dt over dt, the rate of temperature body are equal, proportional to the difference between the body of the temperature and the medium. So in order to convert this one into equation, so we need to find what is the equilibrium for this equation. So to find the proportional, to convert the proportional, you write as equal and plus the constants of proportionality. So let's say the constant is K. So K multiply T minus Tm. And this case, for the Newton law of cooling and warming, so K, let's put as negative because the temperature will be from high to low. So from high to low, let's say this is a negative K. Now, by using the Newton's law of cooling, we get one new equation. So this equation we call the differential equation. So this differential equation, so first you can solve it by using a separable equation, and also it is also linear equation. So you can solve by using separable equation, or you can solve by using linear equation. The simplest one, let's solve this equation by using a separable equation. So let's see this one. So according to Newton, dt over dt equal to negative k over t minus tm. So tm is the surrounding medium. Let's say the room. T is the temperature body. Let's say the temperature of the coffee. So what happened to the coffee? The temperature of the coffee will cooling until it reach the equilibrium with the room temperature. So to solve this one, you can use either separable equation, or you can use linear equation, because both method can be solved. So for solving this one, I would like to use a separable equation. So I need to separate a variable t, capital T, and also the small letter t. So here I find out that this one consists of one variable, variable t minus tm. So I can separate this one as dt over t minus tm equal to minus k multiply dt. Because k is a constant, you can either let it here, or you also can bring k here. No problem. Both can solve by using the separable equation. But this way is more easier. So now let's integrate this one. Since both have a derivative, this one with respect to capital T, this one with respect to time. So you can integrate 1 over t minus tm dt equal to integrations of negative k dt. So integrate 1 minus 1 over t minus tm. So this is equal to ln T minus Tm, integration of minus k with respect to t, so you just get kt. And don't forget constants of integration, let's say c. So we have a ln on the left hand side. So to get rid of the ln, why not? We just apply exponent both sides. So let's put exponent here and exponent here. So if I put exponent to the ln, now I will get t minus tm. Here I have exponent minus kt by using the power rule. When we have a plus, so this is equal to multiply another exponent c. So exponent to the power of c is a constant. Why not we rename this one is a, hence this one is negative kt. And we would like to find the temperature of the body for any given time. So bring the tm to the right hand side. So this is our final equation. So actually this is a function t with time. So this is the solution that we are looking for. So T or temperature at any given time are equal to a constant A to the power, constant A multiply exponent to the power negative KT plus Tm. So in this equation, there are two unknown that we don't know. First is we don't know what is a A, and also we don't know what is a K. The Tm will be given temperature of the medium, and T is whatever time we would like to find. So you need to find A and also K first before you can find what is the temperature at any given time. And let's see example number 12. So let me erase this page first. And then in your notes, make a correction here. This is at 50 degree. 50 degrees Celsius. So let's read this example. A bowl of soup is poured from a pot content 95 degree into non-insulated bowl in a room at 20 degree. After 2 minutes, the soup has cooled to 80 degree. How much time is required for the soup to reach an eatable temperature at 50 degree? So in this question, there are a lot of information given to you. So first you need to identify what is the all these informations given to you first. So let's read this question again. A bowl of soup is poured from a pot contain 95 degree into non-insulated bowl in a room at 20 degrees. So first we have a room temperature. So room temperature, the medium is 20 degree. So first, the bowl of soup, the soup is hot. The first temperature, let's name it T naught. Initially, the temperature is 95 degree. After 2 minutes, let's say this is T2. After 2 minutes, the soup has cooled down to 80 degree. That means after 2 minutes, from 95 degree, it has cooled down to 80 degree. So how much time is required for the soup to reach an eatable temperature at 50 degrees? So now we are looking how much time. So we are finding what is time to reach T at 50 degree. So we are looking at this multi. We want to find how minutes, how much time required for this soup to cool down at 50 degrees. So we need to solve the differential equation. So let's start from the first one, the derivations of Newton's law. So we know that the Newton's law given dt over dt are equal to negative k over t minus tm. So actually you don't need to derive this one, you just need to remember the formula. But in order for you to understand this problem, let's try to derive this one. So according to Newton, the rate of temperature will cool down are equal to the difference between the body and the surrounding. So this is equal to dt over dt equal to minus k times t minus tm. So we know that this tm actually is 20 degree. So we need to solve this one. So to solve this one by using separable equation, let's separate the equation 1 over t minus tm multiply dt equal to minus k times dt. So integrate both sides. So when we integrate both sides, we get ln t minus tm equal to minus kt plus constant c. So put a ln both sides. So right hand side we get t minus tm. Right hand side we get exponent minus kt dot exponent c, which is t equal to a exponent negative kt. Now we need to put all the information that we already note to find what is A and what is K. So first, we have initially the temperature of the soup is 95 degree. So when T equal to 0, the temperature is 95 degree. So 95 equal to A exponent negative K times 0. So exponent 0 is 1. That means A equal to 95. Oh, sorry, yeah. I forget. This is plus Tm. That means this is plus 20. So A equal to 95 minus 20. So A equal to 75. That means T equal to 75 exponent minus KT plus 20. So this is the information that we got so far. We have A equal to 75. Next, we need to determine the value of K. So how to find the value of K? By substituting at T equal to 2 minutes. So we know that when T equal to 2 minutes, the temperature of the soup is 80 degrees. So 80 degree are equal to 75 exponent minus K multiply 2 plus 20. Right, now let's solve this one to find the value of K. So 80 minus 20 equal to 60. So 75 exponent minus K times 2 or 2K. So we have 60 over 75 equal to exponent minus 2K. Take ln both sides. So if you take ln both sides, we have ln 60 over 75. We have negative 0.2231 2231 314 equal to negative 2k. So k equal to divide by minus 2. So k equal to 0.111. Let's take 4 decimal points. So k is 0.116. So now we have full equation. So t equal to 75 exponent negative k, which is 0.1116 t plus tm. Tm is 20 degree. All right, so we have full equation. So we are looking what is time when the soup equal to 50 degree. So when the degree of a soup, the temperature of the soup is 50 degrees, so we need to solve for small letter t. So 75 exponent minus 0.1160 plus 20. So 30 equal to 75 exponent minus 0.11160. So take 30 over 75 f exponent minus 0.11160. Take ln 0.4 is negative 9163 equal to negative 0.11160. So t equal to about 7.899 minutes. So about it will take about 8 minutes. So the soup will take about 8 minutes to reach the temperature 50 degree. So make the conclusion. So it take about 8 minutes to reach a 50 degree. Right, so you can take a screenshot first. All right, so now 6:57. So I will stop here at example number 12. So tomorrow we will continue with example number 13. So tomorrow we will continue with example number 15. All right, so do you have any question?
No,
Sir, the last equation, did it in turn exponents c into a. Which one? Exponent minus exponent c to the power a. This one, exponent c. So multiply exponent c, right? So this one turn into a. Let's rename exponent c to the a because c is a constant, exponent c also a constant. So let's anak saya pun dah panggil lah. Right, so I think that's all for today. The class is already recorded. Don't forget to we give you the link for attendance. Please fill this link attendance. Yeah. Please fill the attendance form We close the attendance form after 5 minutes. So please fill this attendance form first. With that, I dismiss the class. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir. Thank you,
Okay.
sir.
Waalaikumsalam, sir.
Thank you, sir.
Okay.
Thank you, sir.